Yes, can you hear me again and see me? Is it okay now? Okay. So we are making KNX devices, for example, like this daily KNX gateway for DIN rail mounting, other devices for fault ceilings, also KNX to daily gateways. But interfaces, interface is big market for KNX. For example, for energy metering, we make interfaces like this one. This is to put into an existing product that has M-bus, and so it is possible to make a joule counting for existing meters, but also we make more common KNX devices like this one, which is making KNX and audio device with Wi-Fi, Bluetooth, Bluetooth low energy, and you have a SD card, and at the end it is mounted like this in standard frames or custom frames. So we are specialized in making special products according to customer needs. And today we will show you a little bit how we make KNX Aero product with this valve actuator that Peter has spoken about. Okay, so I have no idea about how good or how much experience you already have in developing products. So I will go from A to Z for this simulation, going quite fast, but a little bit on every part. So the first thing is, like Peter showed you, this valve will look a little bit like this. So this valve actuator. So it is to be screwed on standard valves. And then you will have different mechanical parts inside, thermal parts, electronic parts. This I will show you. Let's begin with mechanics. So I need to switch to my screen. So share my screen. I think connection is maybe slow. I don't know if you can see my screen now. Maybe it's still loading. This is okay. So, okay. See my screen now. So this is the device. So we're making, of course, making this device also. So we start at the front part. Everything is getting very low. This is the front part. It is made of aluminium. Peter, I'm asked to switch off my speaker, but my speaker are off. So I don't know where the interference. I don't hear anything from my speakers, but I will mute anyway. It's better now. Okay, fine. Okay. The first part, something is not working like it should expect, like it's expected. Sorry. One moment. Okay, so sorry, something does not work like it should. This is the front part. This part with the tweed the existing valve. Valves are made of metal, so the heat from the valve, from the heater or radiator will go to the valve to this part. From this part, on the back side, we will have this filter element. It's a custom-made element, and this it's called thermal electric generator. Having heat difference between one side and another side, it will create some energy, and this energy we will have it to load the battery of our. So this will be the hot side, and then we will have the made of aluminum also to transfer the heat. So this will be warm, this will be colder, and the difference is making electricity. Then we need here, this gap will be filled with plastic part that has a high thermal resistance, so the heat will not flow to the plastic, but only to the filter element. Then we will have the that we will show later, and this PC valve actuator inside. It's a stepper motor that can push the pin of the valve. It is here visible now. And then for this part not to keep and to keep this difference, we will need a, and this cooler is made of aluminum also, and this will have the ambient temperature, and this will have the temperature of the valve. Of course, it will need a battery also, battery that is inside, and that will be filter element. And then we will have a cover. Of course, on this cover, we have also a label that will cover the screens that I told before, and we have here an USB charging port. So normally this USB charging port will not be used, but if you are integrator and you have these devices on stock for a long time or working a lot, making a lot of tests, then you can connect here your USB connector and charge the battery. Also, if you have an application or maybe you put it on the radiator and for a very, very long time, maybe a year or two, it will never be any heat generated and the battery should get low, you can reload it. Here you have the hole for the KNX button, and here you have the KNX LED. So there are no other elements on it to use. It's very, very simple. But then, of course, inside we have the electronics. Electronics has to be done for this also. It's electronics software, which we will use. I will show you here. Electronics, of course, starts with a schematic. So on this schematic, we have first a processor. This is a device that is making all the calculations and all this. It's really, everything is really slow today. So we have a processor from our colleagues from ST that we see before. So it's STM32. Inside we have a KNX stack. The KNX stack we use in this product is from TAPCO. Like it was told by ST people before. And then we need the physical layer. Physical layer for this device. There is it RF, and for this we use RF transceiver. It is very, very slow, sorry. Try to switch off anything to get it fast, but something is hanging. Maybe I can close this one. So now it's getting maybe a little better. So for KNX US, we have the processor that is required to drive the stack, KNX stack. Then we have the radio interface, the physical layer, is 61211. It is from a manufacturer Sire Wireless. It's some similar component as the one presented by ST. Antenna part with some filterings, and so mostly people are using antennas. Wire antennas are quite simple, are cheap. We rather used a chip antenna. It's more expensive. The chip antenna is device number 10, device number 3000 will be exactly the same. There will be less differences in performance because it will be the same way, and the wire will depend a little bit on things like the chip antenna will be always the same. On this device, we have the first part. Of course, we need a motor driver to drive the motor, to push the pin of the valve, and we have the motor. The stepper motor is very, very precise. I will show you later. Also, very important for this is so we have a connector where we connect the Peltier element, electronic that is able to take out very, very low energy, starting from some microwatt, and to take this energy. So this is a little more complicated part. To gather some energy from the Peltier element as microwatt, and this device is able to doing it, and it's even able to start with voltage to start to work. As on every device, we need also a KNX LED and a KNX button. Everything that is required. We also have the USB connector, the USB charging components here. And together, like this at the end. So you have this. This is a motor, the step motor. We have 5 mm stroke, 5 mm that we're using. The motor indeed has little compensate, but we use 5 mm strokes. This 5 mm, we do it in 2000. We get very, very smooth regulate. Could even do smoother, but it makes no sense. We have the KNX push button. This push button is meters away from the PCB edge because of ESD electricity. If someone near to the device and is charged static electricity, not to destroy the device. Here we have the KNX LED, and this is antenna. Of course, we need to put as less code. So here you have no component, one plane. The same for here. We only have the minimal components, the LED and the temperature sensor. And on the back side, this antenna, we have nothing here, and just a USB connector. These devices. This is a connector for the Peltier. So this is the first thing that we need to be able to do. People are using a demo presented by ST before. Because without having big work, you can have something and play. You make a real device, and the more complicated it is, the more you may have some other effects that may have some incidents. I'd like to do, as we are already experienced in KNX, to draw a PCB that is as near as possible to the final product. This is the second design of this PCB, and it should be the last also. So this is for this. And now, once we have a drawing, we need to make some prototypes. And now I will switch to camera again. So now I'm on camera. I switch to the other camera. Is it better now? It is good? Okay, fine. So I thought once you have a prototype, assembled prototype, then you can start with software development. For software development, what is the best is to have an access to the software that is inside. For this, you will need some interfaces. These interfaces are things like this from ST or like this from other manufacturers. And this you want to connect to your processor. So for connecting to the processor, as the devices are getting smaller and smaller, what I do is we have some special interface, own design. It's something like this. And with this debugging hardware, we will be able to connect to the device and to load the software inside. So this is what we done here. So I hope you can see it. This is the electronic of the actuator. This is a physical interface. It's just a small PCB that we done with some connection, special connection. And this is the interface to the computer. So now that we have this, we will be able to create some software and to load it inside. So now I will switch over to the screen again. So hopefully you see the next step will now to be to create some software. So for software, in this example, I'm using the Tapco stack, but it will be more or less similar with other stacks, I think. So we have first this one. So we have a wizard. With this wizard, we will be able to create an empty project, empty software project. It will start now. So you can give a name to your project, sample project. You can choose the target processor you are using. In this case, this is SD processor. So here you can select different SD processors, the device model of the kind, and the physical layer. This is twisted pair, or in our case, AWF. And then you can generate, and this will with the stack inside. Then we will use, in my case, I'm using mbit. It's a compiler, an editor, where we have our project inside. This is flash switch actuator, bank control, etc., etc. So we have our project. So a KNX device has first, it has a physical address. The physical address, it's a unique address to each device in a KNX installation. So we need to declare the physical address of the device. This is here, physical address. Then the device needs also some communication as the live interfaces to other devices. For example, a thermostat will send a value. Will tell it it's winter or it's summer, things like this. So this you will need some communication objects and some association table. So from here, for example, we will define the object of this value. We will have this is the wrong one. Sorry, this is the wrong project. So this is so for this device we will have, for example, communication object for battery voltage in millivolts, in percent. We will have some flags battery for 0%, 25, 50, 75, 100%. We'll have all this. We will have all this, for example, target position of the motor. So we will tell it, okay, go to 3 millimeters, or we have it in percent also, go to 25%. This object has to be defined. In order to be able to debug something, to make tests, we will give them addresses. These addresses are the same as within ETS. They will be reprogrammed once the integrator will use. But prior to using ETS, we will at this place put some addresses so we can use it. We will have, in this firm, we have to put the addresses, communication objects. We will need to initialize these values, because at the beginning, when the device starts, if it has never got a communication object, it needs to have some value, something, because else it cannot work. So we will give some info values, and also we need some power meters. And maybe, because time may get a little bit short, we'll make a very, very short simulation of this. So we have, this is another part of software where we we have a board file for each device. This is a part, put all the drivers, like something like drivers. We have some temperature sensor, we have some motor, things that are not inherent to KNX, but that we use especially in our. So usually we make one file where we have the stepper motor, temperature sensor, and everything that is really only for this project inside. And so we can test everything. And so once we know, okay, we can drive the motor, we can use the temperature, we can charge the battery. Once we know that the hardware is working fine, then we can validate the PCB, and we can already order and put these PCBs in manufacturing after having done some EMC tests. Application with all the details for software, this we can do parallelly to manufacturing in order to be faster for time to market. Just for example, make a little test. You saw we have an object, PPP, so it's one. You see, for example, here we have a communication object, address 333, and it's of type 7.2, data point type. Now what we do here is we can compile the project and connect it to our prototype. This is going with this items I showed just before. Also, I will activate the camera. I just didn't time to file and to load into device. Very slow, so usually it's much more faster than this. While it is loading, yes, uh, the ETS is a standard software for putting the power meters and communication objects into a KNX device. And here we have a tool called monitor, so you can give an address for TP2, while the address for the motor drive, the data point type was 5 or 7.2, don't remember, and here we put a value, for example, and then we will send it. But here we need compiler has finished, right? Here we have to use to select the interface that we're using. So here it's written Tabco RF USB interface. So this ETS will communicate with KNX using. And now hopefully now sometimes it can be very slow. Okay, hopefully it gets a little faster now. So no memory is written. So now the software that has been generated and written has now been loaded into the memory of the device. Oh, I'm live again. Okay, can you hear me? Okay, okay, fine. Okay, so now you see compiler has finished. The software has been loaded into the prototype, and now we can switch to the other part. So here we have the software. We'll make it one. And now this software, like it is displayed here, is actually running on the prototype. We will put some stop points. So for example, here we have the software is asking if you have got the communication object target position. So here I will put a breakpoint. We have got, I'll send again. So, okay, and we'll and now if we put here some value, 0, hopefully you will see it. Maybe I'll put a, I will stick it. And now you see now here on ETS software, I have told to go to 2000 steps. This is 5 millimeters. And so maybe you see it here. Now it is out, full out. And now I will go back to 0, for example, and you will see it is going back. So this is, as you can see, quite simple. This is the way how to operate together with the software you are writing, the electronic prototype you have made, and the ETS. So for example, now I will put breakpoint here. So he will check until he will get some new value. So you see nothing happens. It is running actually. Now here I will put some target value, 1000 steps for example. I will write. Oh, it was the wrong one, sorry. This is person, this is step. I'm sending on this object. It's still running. And now I'll put it like this. You see here, there is no, just a red circle. And now I will send a value here, for example, 0. I will click on send. And when I send this value, you see here now, you get this yellow mark. And now the software has stopped at this part. So he has checked if you have got this communication object. This communication object is good. So it's stopped here. And now if I click on continue, the software will continue next step. And the drive will go to the new position. So I don't know questions. It's a little bit complicated to explain development, especially KNX, within a short time because we have mechanics, we have things to take care about. We have electronic, we have software, we have the tests. So I think if you have some ideas or some needs in this for this such tasks, maybe the best is to contact one of us. Maybe Amazon, maybe ST, maybe Weinzel, maybe Peter. someone, and so we can check how we can help you to get your product that you want. I just change the camera because I just saw it's not a good one.
Thank you,
So
Alex. It was really nice in your demo. I believe Alex is not here or he left. Anyway, thank you very much for carrying this demo for us. It's not very usual to see in such detail a development from scratch. So really, really appreciate it. So also to all the speakers, thanks a lot for sharing their knowledge. And the audience, thank you for your patience. It was a real life event with a lot of issues with the connections, but we made it till the end. So I'm very happy. We will put this together. We will clean up the video and we'll put it on YouTube. And we'll share with the participants the slide decks and the contact details from the speakers in case you want to contact them. Other than that, thanks a lot. I'll put also my email address in the event chat box, and we will keep in touch. So thanks a lot, and I hope to see your KNX RF developments in the market very soon. Have a good day.